Hello and welcome to Perpendiculars and Distance. This will be the last video of this chapter. And in this video we're going to be talking about finding the distance between a point and a line and the distance in between two lines. And to do that we'll be bringing back some old equations like the distance formula, systems of equations, all the fun stuff. Now the distance between a point and a line, and actually a little bit later on when we get to the two lines, is the length of the segment perpendicular to the line from the point. So what that means is like demonstrated in this picture. You have your line AB, you have your point C. Then you have this line, this perpendicular line that connects the point to the original line. The distance between these two things is the length of this highlighted section, which means, as I said earlier, we will be bringing back the distance formula. And as a reminder, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now the reason we're measuring a perpendicular line is because even though you can draw several lines from point C to line AB, they vary in length. I mean, you have this line over here which swings out pretty long, and then this one's a little bit shorter. The shortest distance between the point and the line, and between any point and a line, is the perpendicular line. And that's why we are measuring the length of the perpendicular line, because that one is the shortest. Now we're going to jump straight into the examples on this one. So here is example number 1. Line L contains points -5, 3, and 4, -6. All right. Find the distance between line L and point P, which is 2, 4. So what we're going to do is what was talked about on the last slide. We're going to find the perpendicular line that connects the point to line L, and then we're going to use the distance formula to measure that line. Now there are 4 steps to this process. Step number 1 is to find the slope of the original line. All right, and then we need to write the equation of the original line. And yes, I just put OG line. So when we do this, we are going to first use our slope formula, which is m is equal to y2 minus y1 over x2 minus x1. So this will be my x1, this will be my y1, x2, y2. So I have -6 minus 3 over 4 plus 5. The negative times the negative is positive. This gives me -9 over 9. My slope is 1. Now I'm going to find the equation of the line, and I'm going to take, I'll take this point. It doesn't matter which one you pick, I'm just picking this one. And I'm going to plug that point and this slope into point slope form. So y plus 6 is equal to 1, that should be a -1. -1x minus 4. And I'm going to rewrite this in slope-intercept form because that'll make my life easier later. So y plus 6 is equal to a -x plus 4, which means our equation is y is equal to a -x minus 2 because you subtract 6 from both sides. Now I'm going to put a box around this because we will come back to it later, and we will need that piece of information later. Now, step 2 is to write the equation for the perpendicular line going through that point. So what I'm going to do is I'm going to take point P and the perpendicular slope, plug it all into point slope form, and then rewrite in slope-intercept. So my perpendicular slope, since the original slope is -1, my perpendicular slope is going to be 1. I'm going to plug that into point slope form using point P. So y minus 4 is equal to 1 x minus 2, which means when I move things over, y is going to be equal to, actually, whoops, y is going to be equal to x plus 2. And again, I'm going to put a box around this because it will be important. All right, now our third step is to determine the point of intersection between the two systems. So this is our perpendicular line, and that's awesome, but we don't know where it intersects with line L. So our next step, step 3, is going to be to find the point of intersection between the perpendicular line and the original line. And the way we're going to do that is by solving for systems of equations. So I'm going to take line L, and then I'm going to name this new one line P, and I'm going to set them up like this. So L goes first, and I have y is equal to a negative x minus 2, and then y is equal to x plus 2. And remember, when you're solving for systems, all you need is one variable to have the same number and opposite signs. And as I look at this, I see my x's are the same number and opposite signs. So now I'm just going to add down. My x's cancel, and I'm left with 2y is equal to 0, which means that y is actually equal to 0 as well. Now I'm going to take this point and I'm going to plug it back into one of my equations and solve for x. So I'm actually going to take line P, since that's the line I'm on right now. I have 0 is equal to x plus 2, which means x is equal to a negative 2, which means my point of intersection is negative 2, 0. And again, a box around it because that's important. Now our last step here is to do what the question asked us and to find the distance between the point and the line, which means we need the distance from point P and our new point, which I will name Q. And here we go. As a reminder, our distance formula is x2 minus x1 squared plus y2 minus y1 squared. So this is going to be my x1, y1, and this is x2, y2. So I have 2 plus 2 squared plus 4 minus 0 squared, which is going to give me 4 squared plus 4 squared, which is going to equal the square root of 32. Now we can't just leave it as that. Always reduce and simplify your radical, which means the distance is 4 square root 2. This is our final answer. The distance between line L and point P is 4 square root 2 units. Now the other thing we need to go over is finding the distance between two parallel lines. Okay, so that was the distance between a point and a line. Now we need the distance between two lines. Okay, and as you all are aware of, parallel lines means they are always, they never touch. Another way to say that is, no matter where you are in either one of the parallel lines, so take this ladder, no matter where you are on the ladder, the distance between one side and the other side has to be the same, which should make sense. Now the process to do this is about 3 steps. Okay, so we need to find, in this example, we need to find the distance between parallel lines L and M with the equations y is equal to 2x plus 1 and y is equal to 2x minus 3 respectively. Now this picture over here, I'll zoom in on it. This picture over here is what we're going to be doing. In order to figure out the distance between these two lines, we need to first calculate 2 endpoints. So one point's right there, another point, we need to figure out what this one is, and find the distance between these two endpoints. And the way we're going to do that is to find the equation of line P, which is perpendicular to both line L and M. And we're going to use the y-intercept of line M, which is this point right here, as one of our endpoints, just because it's a nice point and it has 0 in it, which will make our lives a little bit easier. Oops. Now this problem only has 3 steps, so it's slightly shorter than the other one. And here we go. So to start off, I will change colors. To start off, we need the perpendicular slope. Now we can tell just by looking at our equation that the slope of these 2 lines is 2. So our perpendicular slope is going to be a -1/2. Next, we're going to find the equation of the line. So I'm going to use point slope form and this point and find it. So y plus 3 is equal to -1/2 x minus 0. And y is equal to -1/2 x minus 3. Again, this is going to be important later, so I'm going to box it so that I can find it easily. Now next, I need to find the intersection between L and P. So if you look back at our diagram, I need to find that point right there. Now, line L, to remind you guys, line L is this one right here. So L is y is equal to 2x plus 1, and then P is y is equal to -1/2 x minus 3. Now neither one of those are really going to stack up nicely like the last problem did, so I'm just going to use substitution and set these 2 equations equal to each other since they're both equal to y. So now I have 2x plus 1 is equal to a -1/2 x minus 3. Now I solve for x. I don't particularly like fractions in my equations. You can subtract the fraction, but I prefer to get rid of my fractions. So I'm going to multiply the entire equation by 2. So now I have 4x plus 2 is equal to a -x minus 6. Now this is an equation I can solve quite easily. So I'm going to add my x to both sides. 5x plus 2 is equal to a -6. 5x is equal to -8. X is going to be equal to -8/5. Now I need to find y, so I'm going to take my line P, because that's my perpendicular line, and I'm going to plug x in there. Okay. My 2 and my 8 are going to cancel out, and I'm left with 4. So y is equal to a 4/5 minus 3. Now I need to do a little bit of fraction work. So 4/5, I need to put 3, I need to give 3 a common denominator, which is going to give me -15/5, because multiply the top and the bottom by 5, which is going to give me a -11/5. Which means my point of intersection is -8/5 and -11/5. Now I know I breezed through that math pretty quickly. If you have any questions over the substitution step or just a reminder of how to add and subtract fractions, feel free to ask in class. I will be more than happy to go over this in class. But now I'm going to move on to the 3rd step, which is finding the distance between our 2 endpoints. Our 2 endpoints are this one and our original one of 0, -3. So our first one is -8/5, -11/5, and then we have 0, -3. This is going to be my x1, y1, and then x2, y2. Now I'm just going to plug in. 8 over 5 squared, that's going to turn into 64 over 25. Now I need to do a little, again, more fraction math. So I'm going to come over here and I have negative 3 over 1 plus 11 over 5. I'm going to put this over a common denominator, which gives me negative 15 over 5 plus 11 over 5. And that's going to be negative 4 over 5. Now once I plug this back into my equation over here, I'm squaring it. So I'm going to end up with 16 over 25, which when added together is 80 over 25. But distance is the square root, so my last step is to take the square root of that fraction. So 80 is the square root of 16 times 5. And then, of course, 25 is just, 5. Square root of 25 is 5. 16 can be reduced further, and I have 4 square root 5 over 5. Or you could also say the distance is 1.8 units if you were to plug this into a calculator. So either of these answers will suffice. It just depends on what your instructions say. If your instructions say leave it as a simplified radical, then the fraction is what you're going with. If the directions say reduce or given as a decimal, then do it as a decimal. And that is it. If you have any questions on either the concepts or the math, please write them down and I'll see you in class.